Hello, good morning. Today we're going to discuss data collection and presentation. Now, when you are conducting your research or your data gathering strategy, take note of the following ethical considerations on data gathering. Number one, your questionnaires must be anonymous. 5 years from now, or 10 years from now, or 20 years from now, your sons or daughters might be reading the results of the experiment. So we don't want our children to know what we do when we are young. So please avoid stating the names of the respondents, um, attaching questionnaires or filled up questionnaires at the end of the research. So all information gathered must remain anonymous. The questions should be carefully written to avoid bias and should not be opinionated or misleading. Inasmuch as you want to highlight the results of your research, so please avoid biases on your line of questioning. So make sure that if someone from the other group would be reading your questionnaire, they would not be offended. Participants have the right not to complete any particular items in the questionnaire and to withdraw at any point during the study. For observations, in overt observation, it needs to be considered that the presence of an observer may be threatening and may exert an influence or behavior. So the observation should not be overt or should not be threatening, as it may change the behavior of your respondents. So they might be having a different behavior if they know that you're there. So, say for example, you should not be observing your children or your children when their parents are there, because they might be having a different behavior. As for the covert in observation, they must be having an informed consent. They should know that you have gathered the information from them. So, informed consent hence should be used only in situations where there's no other alternative method. For interviews, there always be confidentiality. Remember that an interview is a personal interaction and everything recorded needs to remain confidential to protect the participant. There should always be the confidentiality agreement. And at the end of the research, go back to your respondents after doing the interview, and can what is being said and what is being recorded be misinterpreted? So this is somewhat the violation majority of broadcast media is doing. So they are presenting something which is not really the intent of the one being interviewed. So avoid misinterpretation and misrepresentation. So to easily present or to gather data and to present it numerically, a scale was designed by Rensis Likert. A Likert scale is a scale commonly involving uh, numbers, scales 1, 2, 3, 4, 5, a rating scale, uh, to applied to be applied in questionnaires. It is the most widely used approach to scaling responses in survey research. So, an example of a Likert scale would be 1, 2, 3, 4, 5. Strongly disagree, disagree, neither agree, nor disagree, agree, and strongly disagree. Strongly agree. It can be 1, 2, 3, 4. It can be 7 point. So, these are different Likert scales available. Now, in data gathering, if you collected the data from the entire population, it would be a population data. and all variables are considered. So it is the variables that you're going to consider from a population data gathering would be a parameter. While example would be there are 2,500 students enrolled in Math 146. So the population are the students in Math 146 and the parameter is 2,500. If we're going to collect a data from this population, we call that representation as the sample or a small group taken from the population. It must be heterogeneous as possible. It should represent the entire population. And the data that we're going to gather from the sample is what you call statistic. Example, out of the 5,786 students enrolled in Math 10-1, 3,456 are females. So the sample is the female students in Math 10-1 and the statistic is 3,456, the sample. So from the population, you obtain a small group and that small group sample is a representation of the population. Now, statistics can be is the science of collecting, presenting, analyzing data for the purpose of implying a good decision. Now, it can be divided into two, the descriptive and inferential statistics. Descriptive statistics is used to summarize or describe the important characteristics of a known set of population data, while inferential statistics analyzes a small group of data gathered from a bigger set of data for the purpose of interpretation or for the purpose of generalization. Example, last school year, there are 2,000 students from Mapua Senior High School in Intramuros and 800 students from Mapua SHS Makati. This is descriptive because it describes the population data. So this is descriptive. A recent study showed that garlic can repel mosquitoes. So this study is taken from a small group of sample that represents all the garlics and then it checked whether it repels mosquitoes. So this is a small group of analysis and then it was applied as a whole, so this is inferential. Cigarette smoking is associated with 25% of the 2,500 new cases of lung cancer in 2005. So there is a data of 2,500 and 25% of that would be 625. So 625 out of 2,500. So I think this is descriptive because it is just describing the gathered data. And then a survey says that 1 out of 50 Filipinos is a member of fitness center. 1 out of 50. But we know that the number of Filipino is so much higher and a survey cannot do that. So you can get a representation of the Filipino people and then check how many are members of fitness center. So I think it would be inferential. So descriptive, inferential, descriptive, and inferential. So our answers are correct. Now, if you have your population and you get a representation of this population in terms of a small group, so you have a sample. And the process of getting a sample from the population is what you call the sampling. There are different ways of effectively getting your representation of your population or different sampling techniques. So we use the lowercase n as the representative of the population, capital N. Sampling is the basis for inferential statistics. It takes less time, costs less, and a little bit more accurate, and randomization makes the sampling more reliable. So there are two general ways of sampling. The first one is the probability sampling. The second one is the non-probability sampling. Probability sampling is a sampling in which each element of the population has a chance to be selected as a sample, while the non-probability sampling is a sampling technique wherein the members of the populations are not given equal chances to be selected. On previous ways of randomization, we have the random numbers from the back of most of the old statistics books. We also have the run function on your calculator. I think you played with this when you are in high school, the random number generator. So it generates random numbers. So for the different random sampling techniques, the first one is the simple random sample. For the simple random sampling, samples are drawn from a population using a method such as lottery, computer or calculator generated random numbers. So what you do here is, this is the fishbowl technique. You place everything here and then you randomly pick one. So that is a simple random sample, randomly picking an element from the population. So that's a simple random sample. A stratified sampling subdivides the population into at least two different subpopulations and that share the same characteristics such as gender, and then draw a sample from each stratum. So stratum is the different groups. So what you do is you have group 1, you can have another group, group 2, you can have another group, group 3. So each group has the same characteristics. So what you do is to get an element from the first group, an element from the second group, and an element from the third group. So that would build your sample. So that is stratified sampling. So each group are your strata. Systematic sampling, choose some starting point and then select every kth element in the population. So you have 1, 2, you arrange them and then you observe a pattern. So say for example, what you're going to do is to divide them into 3 elements each. And then what you do is to get the second element. So this is my sample, the second element in every group of 3. So this is a systematic sampling. Have you noticed that when your temperature is being taken, so your temperature is taken every 4 hours, so that is a systematic sampling. Next is the cluster sampling. Let me erase this first. Cluster sampling divides the population area into sections or clusters, and so you have different clusters. So cluster 1, cluster 2, cluster 3, and cluster 4. Now each cluster has their heterogeneous characteristics. So each cluster is obtaining different characteristics. Now, instead of getting representation from each, what you do is to get the entire cluster as your sample. So, say for example, geographic location. So, instead of surveying one representative from Bulacan, one representative from Laguna, one representative from Cavite, what you can do is to get the entire Bulacan as your sample. So that's your cluster or your cluster sampling. For the non-probability sampling techniques, so some elements um, are not having their chance to be selected as sample. So the first one is the convenience, haphazard, accidental sampling. Uh, Usually on your research you say that it is a random sampling, but most of the time it is just convenience or haphazard or accidental sampling. So what do you usually do? So you ask your friends, co-workers, family, shoppers at a single mall, and when you reach your um, desired number of respondents, then you stop surveying. So if the data is quite difficult to manage or to gather, they are not usually part of the respondents. So that is the population that does not have a chance to be selected as a sample. So first, convenient sampling. Second is the snowball sampling. So for snowball sampling, the first respondents refers to an acquaintance, a friend. The friend also refers a friend, and so on and so forth. So such samples are biased because they give people with more social connections an unknown but higher chance of selection, but lead to higher response rates. So there is a chance that you're going to get the same response because you're getting the response from a friend of a friend of a friend. So that's for snowball sampling. Referral is the key for snowball sampling. For judgmental sampling or purposive sampling, based on your judgment, you select a specific respondent because it would satisfy your need for your research. So say for example, you want to get the responses or the responses from online education. So you purposely get the reactions of Mapua students because we are quite pioneer in online education. The other institutions are just following us in terms of the possibility for an online education. So if you want to get response regarding online education, you ask an online, the Mapua administration, the Mapua students, and the Mapua teachers or the faculty members of Mapua University. So the researcher chooses the sample based on who they think would be the appropriate who would be appropriate for the study. This is used primarily when there is a limited number of people that have expertise in the area and when the interest of the research is on a specific field or as a small group. So we use this purposive sampling for the deviant case, meaning so somewhat the dominant population. You also have it for case study for a very small group for the non-deviant case, and then a quota sampling for a specific number of responses. You might wish to identify the sampling techniques for the following cases. You may pause this and answer the following items. These are our references for the previous discussion.